It's time for the next section, which is you've got a solid foundation and you are now ready to move over to the modern language in which to make Android apps, which is Kotlin. I'll be doing a more detailed introduction to Kotlin in the next video, but in summary, Kotlin is a really fun, enjoyable. It fixes a lot of the problems of Java, a lot of the code which we have to type, which is quite long and cumbersome. It fixes a lot of those problems. And I remember before I first tried using it, being a bit nervous. I was thinking to myself, you know what, I've only just started learning Java. Do I really have the headspace for Kotlin? Am I going to find it a long time? Is it going to be frustrating? And I can tell you, honestly, it took me no time at all to learn Kotlin. I immediately found it more enjoyable to use, easier to use, and since I've switched, I've never looked back. So in this one section, you too are going to make the switch to Kotlin. You're not going to find it difficult. It's going to be enjoyable, and it's going to be a fantastic skill for you to have as a modern Android developer. The ability to code not only in Java, but also in the modern language. Okay? So the primary objectives for this section are, number one, to be able to program in Kotlin. So by the end of the section, you're going to be able to make full Android apps entirely in Kotlin. Your code's going to look nicer, it's going to be more modern, and it's going to bring you right up to date with the latest best practice. And the other objective for the section, so that we're not only focusing on programming languages, but we're actually focusing on new important skills in making Android apps, we're going to understand how to pass data to a new activity or screen. Okay, so we haven't actually covered this yet. We've made classes, we've done recycled views and lists, and we've created data within one activity, but we haven't actually passed it to a new screen. And actually, a new screen is a completely self-contained, independent, focused thing a user can do, if you remember from a previous tutorial. So this ability to pass data from screen to screen is absolutely crucial if you want to make a nice flow for your users when they do these individual focused things. So that's the two primary objectives. And the project for this section, through which we're going to learn all of this, is the Shameless Self-Promo app. So in this section, you're going to make an app which is going to be a marketing tool for you, the developer. So on one screen, it will have a form where you can type the name of the person you want to promote yourself to, their number, you can type your name, there'll be a checkbox for whether or not you want to include the word junior when you introduce yourself, there'll be a drop-down field giving you a couple of different options for how you want to refer to yourself, Android developer, Android engineer, and then the ability to say immediate start date or provide a specific date. So that will be on one screen, and then when you click preview message, it will pass all of that data to another screen, which will be the preview of a pretty well-formatted introduction message that you can use in your real life to promote yourself. And then, just for some icing on the cake, when you click send message, it will use one of those implicit intents, this time to go to your text messaging app. So previously we did one for the email, where we did an implicit intent to send an email, and that launched Gmail on the phone. So this will be a different type of implicit intent that will launch the phone's text messaging app. So, as well as the primary objectives, there'll be a few more programming concepts, big, important areas of understanding in programming as a whole. So we're going to learn about null, what it means when a variable is null. We've maybe seen this once or twice, but we've not really talked about it yet, and it's very important, especially in Kotlin, as null can cause all kinds of problems and errors, and Kotlin, this modern language, looks to overcome many of these issues with null. So we'll cover null in detail. We're finally going to get access modifiers, so these words, private, public, protected, you may have seen, and this will link very well to how Kotlin has some defaults for these to save some typing, okay? And then the final programming concept will be serializable. So this is the idea of taking some programming code, a class that we may have written, like dishes or projects or one of these data classes we've made, and actually storing that, saving that to the phone, and then reading it again. And that'll be a really important part of us passing data from screen to screen. As well as the primary objective and the programming concept, there'll be many secondary objectives, and a few of those include understanding how to read the Android logs, or logcat, which you might have seen at the bottom of the screen. If you've ever clicked this or had any problems with your app and trying to work out why it isn't running, you may have seen hundreds upon hundreds of lines of logging of console output, okay? So we can understand how to read that and what to look for and how to filter that down. And then directly related to that, we can actually be able to debug an Android app. So this means when we have a problem, we're going to be able to do clever little things and put breakpoints which will pause our app halfway through running and actually isolate what the problem is. So we're going to be able to do that in this section. We're going to know how to use strings.xml to store strings and understand how internationalization works. So we've seen many, many warnings in our layout code about hard coding strings, typing strings in directly in the layout code. And we're finally going to fix those warnings and do it the correct way, technically speaking, which is to store them in another resource file called strings.xml. And later on, this can help us if we ever need to do our strings in different languages. And then related to this, we're also going to know how to use styles.xml, another file you'll find in the res folder. And we're only going to do a very simple thing with it in this section, which is to change our app's theme colors. So very quickly, we're going to be able to change the toolbar color, the button color, and the status bar color, which is the thing above the toolbar. Okay? So as well as the primary objectives and those programming concepts, lots of other very, very useful things we're going to cover in this section. And then finally, as always, we're going to introduce some more Android widgets, some more views to build up your library of things that you know, of widgets that you can use in your own projects. So we're going to cover a spinner, which is a simple drop-down field in Android. That's what they call the drop-down. And I've given you two screenshots there to show you what's before being clicked and what it looks like after it's clicked. We're going to cover a checkbox, which is a fairly standard thing you see both on phones and on the web. Okay, this is a checkbox that can be toggled on and off. And quite exciting, we're going to cover a text input layout, and by extension, a text input edit text. So these are super-powered edit texts. They combine the hint and the label for the field. So you can see there in the screenshot, contact number is highlighted, contact name is not, so that's grayed out, and then my display name doesn't have any value in it. But when the user clicks on that, the words my display name, that hint, will float above like contact number. Now, you may have seen this both on phones and also on the web, and it's a key part of this material design, this Google standard design specification. Okay, so we're going to learn how to use these, and once we use these, we're pretty much never going to look back when it comes to using edit text. It's just such a convenient. So let's dive straight in and make a new Android Studio project in Kotlin. So I'm back at the Welcome to Android Studio dialog. If you can close down any previous projects and do the same. And we're going to click Start a new Android Studio project, ensure empty activity is selected, which it is, and then click Next. For the application name, you may have seen in the section overview that I decided to call the app the Shameless Self-Promo app, okay? This is just a joke, really. Sometimes I can find marketing or promotions or sales to be a little bit annoying, and now I'm the one who's going to be marketing myself, so me saying shameless is a sort of personal joke. Feel free just to call it the Self-Promo app if you want, or my marketing app, or whatever you want, really. I'm going to stick with the joke name just for a bit of fun, so the Shameless Self-Promo app with a hyphen. If you look at the package name, you can see it's done it all as lowercase, but you can't have a hyphen in the package name, and it's put an underscore. And to be honest, I don't really like the underscore, and it's a bit long anyway, so I'm going to remove all of that and just change it for just Self-Promo app. Remember, for the package name, it can be anything you like, really, as long as it's unique if you want it to be on the App Store. Okay, save location is fine. And now for the exciting bit, we're going to change, finally, the language from Java to Kotlin. Okay, so this is the big moment, the big switch. Ensure the minimum SDK is API 21 now, Lollipop. Change it to this if it's not, and then click Finish. Okay, so mine is finished loading, and I'm just going to close the project pane down so we have the code full width. And it's time now for our first, then click finish. Moment, the big switch. Ensure the minimum SDK is API 21 now, lollipop. Change it to this if it's not, and then click finish. Okay, so mine's finished loading, and I'm just going to close the project pane down so we have the code full width. And it's time now for our first look at Kotlin code. Okay, so at this point you might be feeling a bit overwhelmed, or you might be thinking, this looks quite similar. Whichever way you feel about it, the key takeaway is, there are a few subtle, small differences, but for the most part it is very, very similar, okay? Now, in this tutorial, this first look at Kotlin code, I don't want to go into too much detail about classes, methods, and variables. We'll do a deep dive into those in the coming tutorials. But it will be good to do an overview with a quick side-by-side. So what I'll do is I'll pause the video now and open up a new default Java project, okay? And we'll go over them side by side, see what's similar, and then see some of the few initial differences, okay? So I'm going to pause the video now. Okay, so on the left we have our Kotlin self-promo app, and on the right I've just made an example Java app, which is our Java code. So I'm going to expand the imports on the Kotlin project, so that looks similar, okay? And I will just put the method you see here in a bit of space, and I'll put a line break either side, a couple of line breaks. Okay, so going over it, hopefully you do see initially much of it is similar, if not both. Okay, and this is one of the great things about Kotlin. Anything that is kind of a typical default thing you've got to do all the time, like semicolons or certain keywords in our classes and methods, if they occur very commonly, then you don't have to type them and Kotlin will put them in for you automatically. Okie doke. So, no semicolons in Kotlin. The package and import lines are otherwise exactly the same. If we look at the class block, you see here on the left in Kotlin, and then on the right in Java. So we still have the word class and the name of the class. Class main activity, yeah. And with inheritance in Java, we have the word extends, and then the parent class, extends and the superclass. While in Kotlin, rather than making us type the word extends, which you have to type every single time you do inheritance, it just replaces it with a semicolon. It's such a common thing when you do a class to often use inheritance or extend something, that they've just made it a single character. And then we have the name of the superclass, the name of the parent class. Okay, in Kotlin we have a couple of braces that looks like a method, or in this case actually a constructor. And later on we'll do a Kotlin Foundations tutorial on how classes work in Kotlin, and we'll understand how inheritance and this kind of thing really works. But hopefully you're seeing it is a lot less code to do a class with inheritance in Kotlin than it is in Java. Some things like the word public, which are really, really common in Java, public class and public methods, as a sensible default, Kotlin just says, you know what, if you don't specify one of these things, we will do public by default for you. Okay? So again, it's these sensible defaults, these sensible little things it puts in automatically to save us time typing and to make our code look a bit smaller and a bit tidier. We come down to the onCreate method in Java. We have this @override annotation, which is really common in Java and Android. You're going to be overriding methods a lot, especially in activities and in recycle views and whatnot. Well, rather than having this override annotation with a weird @ symbol taking over a whole line of code, now it just makes it in line next to the method. Okay? Now there's a couple of differences in terms of the return type, void return type, and the way the parameters happen. But you still get the name of the method, you still get the brackets where your parameters go. Okay? But one thing Kotlin does to provide a distinction between classes, constructors, and methods is this word fun. So in Kotlin, they call their methods functions. Okay, so you can think of function and method to be synonymous for the most part. They basically mean the same thing in Kotlin. But in Kotlin, unlike in Java, you actually have to say that it's a function, that it's a method. And we do that with 3 simple characters, the word fun. And I quite like that because I do find coding in Kotlin fun, so I like that I get to type the word fun when I'm writing programming code. So what we get is the word fun that tells us this is a method, this is a function. And this helps us differentiate between classes, constructors, and then indeed our methods. And then if you actually look inside the method, inside the function, apart from not needing semicolons, the rest is exactly the same. Kotlin still does super methods, the app compatibility super onCreate, just like Java, the same way, and it calls the set content view method the exact same way. So I'm going to leave this quick first look at Kotlin tutorial video here. The key takeaway I want for you is that there are 1 or 2 small differences, and the most important of the differences we're going to cover in individual tutorials. How variables work, how methods work, how classes. We'll do a deep dive to make sure you fully understand that in Kotlin. But apart from those few small differences, a lot of it is very similar, if not the same. And as you move over to writing code in Kotlin, you're going to find yourself typing less code. You're going to find yourself facing less errors for forgetting to type words you might not remember or putting semicolons at the end of the line. Okay? If I just make this full screen again and remove these line breaks. And the final key takeaway I hope you're seeing from this first impression is that Kotlin code. So this tutorial is called Why Kotlin? The purpose is to provide a bit more information on Kotlin, the background, some facts and interesting things about it, before we dive into the Kotlin Foundations tutorials where we start to learn in detail some of the main differences. It's also an opportunity to answer any questions that you might have about Kotlin at the point in the course where we finally make the big switch. Okay? So the big 3 questions I want to clear up in this tutorial is, what is Kotlin? Why use Kotlin? And then if it's so great, then why not learn only Kotlin? You know, like why did we go through learning Java first? Okay, so hopefully I'll answer these questions for you in this tutorial. So first of all, what is Kotlin? And I've taken a quote here from the official kotlinlang.org website. This is the official home of the people who make Kotlin. So Kotlin is an open source, statically typed programming language that targets the JVM, which stands for Java Virtual Machine. We'll get into that in more detail in a moment. So it targets the JVM, Android, and JavaScript and native, which we don't worry about at the moment. It's developed by JetBrains. Okay, so JetBrains, in partnership with Google, actually make Android Studio, the software that we use, okay? So the project to make Kotlin started in 2010, and it was open source from early on. So this means that, yes, it's developed by JetBrains, but the code is public. They make changes, they put it to the users, to us developers, they ask us questions, they ask for feedback, they let us look over the changes. As a general rule, when software is open source, that's usually a good thing, because it means more transparency about the changes and more developer input, so we get to be part of helping it advance and become even better. So the project started in 2010, but the first official 1.0 release was in February 2016. Okay, so it's actually relatively new, you know, just over 4 years old since its public release. To put this in context, Java, which we've already learned, well, that was launched back in 1996, so 20 years earlier. Okay, so Kotlin is 20 years younger than Java, and being so new and learning from all the mistakes of Java presents it with a great opportunity to really improve and make a change for the better. Just covering one or two other things in this quote from the Kotlin website. So when we say statically typed, Java is statically typed, where you have a variable of type string or type int. Okay, so it is similar to Java in that respect. And in terms of it targeting different things, the Java virtual machine or Android, we'll be covering this in a moment where we talk about the idea of where it is your code runs. What's the environment where you give a machine, whether that's a phone or computer, what is this environment? What is the thing that reads that code and does stuff with it? Okay, it's giving you 4 different types of environment there: JVM, Android, JavaScript, and native. So that's a brief overview of what Kotlin is from the makers themselves. Okay, so this is an overview of how Kotlin works on Android. And to do this, we need to do a slight deep dive into how any code we write, whether Java or Kotlin, how that works, how it gets converted, how it gets read, and then how it translates all the way down into performing tasks on the device. We talked about this a long time ago when we first learned about programming languages. So first of all, the code runs on the Android runtime, known as ART or ART. Okay, on older versions of Android, we're talking pre-Lollipop, so pre-API 21. On older versions, it's the Dalvik virtual machine, or DVM for short. Okay, but anything Lollipop related, it will be the Android runtime. This is like Android's version of the Java virtual machine, or JVM. Now, don't worry if you've not heard about the JVM before. As mentioned earlier, this is the environment where the code runs. So when you've got your phone turned on, there is a process, a thing, which is waiting to receive the code that we write, this runtime environment. So when the phone is running, it receives this code, and that is the thing that understands the stuff that we type, or actually to be more correct, the bytecode of what we type. Okay, so there's this environment, either the Android runtime or on older phones, the Dalvik virtual machine, that is running when our phone is turned on, and this is the thing that understands the language of what we're making. And then that in turn translates that into things the phone can do, whether that's connect to the internet, show some pixels on the screen, okay? And once you get past this runtime environment, then you're talking machine code. That's where it's all ones and zeros. We don't care about that, okay? You don't need to know too much about the Android runtime. It's not important to have a successful career to have much knowledge of the inner workings of it, okay? But it is good to know that fundamentally, any code that we write ends up being interpreted, read by this runtime environment. On a computer, like Windows, it would be the JVM, the Java virtual machine, and on Android, if it's Lollipop related, it will be called the Android runtime, okay? So if we look now across to the diagram on the right, we can see the flow of this. So we write either Java or we write Kotlin, okay? So we can choose one of those two top-level, high-level languages. Nice and human-friendly, easy for us to understand. Then the compiler will convert this into Java bytecode. Okay, so this is the first important concept here. Whether we write Java or Kotlin in our files, the Java will have the Java compiler and the Kotlin will have the Kotlin compiler, and they will each convert their language into the same Java bytecode. Even if you write Kotlin, the Kotlin compiler will convert to Java bytecode, the exact same Java bytecode as if we'd written it in Java. And that's a really important thing to understand, okay? Now this word compiler, just a posh word for a computer process which converts our code into some slightly more difficult to understand code usually. Okay, so we write something that's human friendly, and then a compiler will convert that into some other code. In just a moment, I'm going to show you what this bytecode looks like. It's not ones and zeros, it's not the machine code that the Android runtime is going to be dealing with. We'll probably never see that. But it's like a slightly more difficult to read, more technical looking, but long and cumbersome version of our previous Java code, okay? So, to confirm those 2 points, the Kotlin compiler converts Kotlin code into Java bytecode. And this is the same Java bytecode that will be created if we wrote our projects in Java. Let me jump over now to our new project, into one of our Kotlin files, just to show you what this Java bytecode looks like. So just in our new Kotlin project, to show you a little bit of this bytecode that I'm talking about, and also a bit about what happens when you build your project. So when we click the play button, when we run our code for the first time, a new folder will pop up in our app folder on the left. You see here in the project pane. And this is the folder in orange. Now, as a rule of thumb, we don't ever want to be touching or messing around with anything in the orange folders. So you can see there's a couple of orange folders here and there. This is automatically generated code, okay? But if I just expand to show you, you can see we get these subfolders in the build folder, and we get this intermediates folder, yeah, with a whole heap of folders there. So when we run our code, the Kotlin, or Java compiler, if we're writing Java like before, will read our files, and it will generate a whole load of new files. And those files will be in the build folder of our app folder. It's not a folder we're ever really supposed to touch or mess around with, and it's in here that our bytecode and the compiled code will be saved. I'm going to close the project pane down to leave the code full width. I'm going to go to a useful little thing that exists that you will never really need to look at, so don't worry about remembering this. But I can go to Tools, Kotlin, and then Show Kotlin bytecode. So let's click this. I'm going to drag it across to be half the width. And if we look down this, it's a very difficult to read, very cumbersome. As you can see, lots and lots of lines and numbers and paths. It's not very user-friendly. I personally would hate it if I had to type this when making Android apps. But if we scroll to the very top and actually look at it, public, final, class, main activity, extends, and then protected on create, it's actually Java. This is not Kotlin bytecode. There is no Kotlin bytecode. This is Java bytecode, okay? So we write Kotlin files or Java files, and they both get converted to this, okay? I can click decompile to see what this would look like if it was in Java. Okay, so if I click this now, I get a new file. Okay, there's some extra junk here, these grayed out methods. But if you actually look at it, public, final, class, main activity, extends out compat activity, protected void on create, bundle, saved instance state, set content view. Okay, it's actually very similar to the Java code we've seen before. A few little differences, a few extra performance things like a view cache that we don't need to worry about, but hopefully you're understanding the concept that whether we write Kotlin like this, or if we write Java a bit like this, it's going to end up as the same Java bytecode. And this is how Kotlin works, and this is how we're able to write Kotlin that works with Java code, and Java code that works with Kotlin code. It all fundamentally ends up as the same Java bytecode. And Java bytecode is not a language that we ever need to understand or even look at, really. Okay? So back to the presentation. Now the final bullet point says, from the point of it being in Java bytecode, from there, the process of making it to the runtime environment is the same. Okay, so whether you write Kotlin or Java, it will become Java bytecode. It goes through another compiler even lower down, a Dex compiler. Don't worry about remembering this or understanding this at all. And that will convert the Java bytecode into an even more, in my opinion, difficult to understand code. An even more lower level code, as we call it, closer to something that the computer can directly understand. Okay? So our Java bytecode gets compiled again by a Dex compiler. Don't need to worry about this. That makes Dex bytecode, which is horrible to look at, and that gets given to the Android runtime, the ART, or the Dalvik virtual machine on older phones. And at that point, this runtime environment, this running process in the phone that separates our apps to make sure that the apps don't cross over, and if your app crashes, it doesn't break the phone, this runtime environment takes care of it from this point. And that's the thing that ultimately makes the ones and zeros to show pixels on the screen, and sound coming out your phone, and all of those physical physical things that a computer or a phone can do. Okay? So, key takeaway, Kotlin compiles to Java bytecode, just like Java. So moving on, why use Kotlin? So again, quoting from their website, Kotlin is more concise. Rough estimates indicate approximately a 40% cut in the number of lines of code. It's also more type safe. For example, support for non-nullable types makes applications less prone to null pointer exceptions. Okay, so in this section we are going to do a programming concept on null, something you may or may not have seen before. It's a major problem with Java, a variable being null, and then trying to do something with it and it causing the app to crash. Major problem. We'll do a deep dive on this in that programming concept tutorial, but Kotlin has some language-specific tools and support to help prevent this, to help overcome this, so it's never a problem again, okay? As well as many other type safety things when we talk about variable types and whatnot. So, taking this again from the website, so they mentioned concise. Kotlin drastically reduces the amount of boilerplate code. We've seen a little bit of this in the second tutorial where we looked at the new project, but you're going to see later on in detail the extent to which we type so much less. Okay, whether it's sensible defaults or reducing things like those on-click listeners you've seen where there's new, view, on-click listener, and all those lines, you're going to see how much smaller and more concise it is. We've mentioned before just then safe, avoiding entire classes of errors such as null pointer exceptions. So we're going to see very soon some of these safety mechanisms and ways they can prevent these. And the final one on the website is interoperable. Leverage existing libraries for JVM, Android, and the browser. So forget the JVM and the browser, but leveraging existing libraries for Android, you can use Java libraries. You can even write your own Java classes, and it will still work with your Kotlin code. Okay, you can swap Kotlin for Java, Java for Kotlin, because it all compiles to the same Java bytecode. It doesn't matter, it doesn't make a difference. So it's really flexible to use, to move old projects over to, or to make brand new projects that use slightly older libraries or Java libraries. Okay, so there are many, many benefits to Kotlin. Just showing some stats very quickly. So this is correct as of September 2020. It's from a website called appbrain.com. They specialize in analyzing app installs, the Play Store, downloads, percentages of apps and demographics and all that kind of thing. So from left to right, as of September 2020, the overall app installs, this is everything from the Google Play Store, the overall app installs that contain Kotlin is 28% of all apps. Okay, so that's quite a significant proportion. Now, what they call new app installs, so percentage of apps that have been made more recently, that then rises to 38% that use Kotlin. So as new apps are coming out, more and more are starting to move over to Kotlin. And one of the most important I want to take away, the top 500 apps in the US Play Store. So this is the best, the highest performing, the most downloaded, the big apps, the Facebooks, the YouTubes, okay? These top 500 apps in the US Play Store, 67% of them use Kotlin as of September 2020. This is what the pros do, this is what the big apps do. The majority of them use Kotlin, and I really think that you should too, okay? It's new, it's modern, it's easier, it's less code, it's cleaner, faster to understand, it has safety mechanisms and improvements that solve a lot of the problems of Java. That language is 20 years older than it, okay? Many, many benefits. It's the way that many app developers are moving. You in your Android career, you're going to work for a company that's likely going to want you to know Kotlin, because it's the language of the future, it's the way that things are moving, okay? Which then leads to my final question I want to answer for you. So why learn Java first? You know, if it's so great, why not only learn Kotlin? Why do I spend so many choices in this course going through Java and JavaScript? Something that you're saying is maybe better. This is slightly a matter of opinion, but it's one that I stand by strongly through having gone through both, and from now being a senior Android engineer, I can tell you the value of this. So, 3 reasons really. Reasons why understanding Java is a big benefit. So many libraries are still written in Java. When we click through to see the behavior methods and classes of libraries, and a big example of this is app compatibility. If you were to command click or control click on set content view, that library is in Java. Many of the Android libraries are written in Java. They still work, they're rock solid, they've been thoroughly tested. They saw no need to switch them over to Kotlin. They wanted to provide some extra support to some legacy apps that are still using only Java and for which there may be some performance issues if they were to switch to Kotlin. So they've left them in Java. We can then more easily understand that code if we know Java too. There are many libraries that are out there that are still in Java, not just the Google or Android ones, okay? And if you want to really know what's going on there, yes, you're going to know Kotlin, but you're also going to know Java. You're going to understand what's happening, and it's going to make you a better developer. Kotlin can mask some of the underlying behavior of the code. So Kotlin aims to be concise, easy, look clean, but this can mask what's really going on. So this concept on interfaces, visibility modifiers that are coming up later in this course. They do some clever things to massively reduce the amount of code that you need to type, but in doing this, you might not really understand what's going on, like what an interface is. So when we do an on-click listener, what's really happening there? Because in Kotlin, an on-click listener is very easy, but it will help you to understand what a view.onClick listener interface, as it is. It will help you to know what that really is. So by only learning Kotlin, you kind of miss the opportunity to really dive in and see what's happening there. So if we understand Java, we understand these shortcuts in Kotlin, so we ensure a deep understanding of our Kotlin code. So you're not only going to know these wonderful Kotlin shortcuts, you're going to know what they're doing in terms of Java, so you're going to understand Kotlin code that little bit stronger, okay? And the final point, Java is still incredibly popular and common. Java is still the second most popular programming language, and this is true as of September 2020. It's from the source you can see there, to.com, the TO index. Not sure how you pronounce that, but it's a universal measure of all of the programming languages that are out there. It's not a list of what's the best or which performs the strongest. It's ranked by how many people are using it, how many jobs are available in it, how much code is written in the language. And it's presently number 2, okay? So knowing such a popular language as this, a second language to your Kotlin, is only going to be a strength to you, making you a well-rounded developer. There's going to be no harm to you knowing more than one language. It's going to make your CV look stronger. As well as this, if and when you get a job as an Android developer, you may need to work on an existing project, a slightly older project, which is in some ways written in Java. This may happen to you in the future. They're going to ask you to convert it to Kotlin. They're going to ask you to maintain it, to develop it, okay? And you're going to stand out so much stronger as a developer that knows both Java and Kotlin than a developer who only knows Kotlin and can't work without Java code. So that's 3 big reasons why you knowing Java is a massive strength. That said, from this point in the course, we're going to heavily focus on Kotlin. We may refer back to Java when we do some programming concepts, but for the most part now, it's all about Kotlin. It's going to be super quick to switch over because it's so easy, very similar to Java as you've seen. So let's get to it with our first Kotlin Foundations tutorial coming up next.